In this video, we'll look at equations of circles. So, first off, let's take a look at a circle. And for the sake, let's say it's centered at the origin, just for starters. So in the first part of this video, we're going to be explaining where the equation comes from. That way you have an understanding of where it comes from. But ultimately, once we get to the end, there'll just be an equation. You can use it, plug and chug. I just want to give you some kind of understanding of where it comes from. So if we think about a circle on the coordinate grid, it has a radius, and each point on the circle has a coordinate x, y. Now you may notice right here, if I think about a circle, it does not pass the vertical line test, so it's not a function. Meaning that for each x I plug in, there's not just one y that it goes to. It might have two. In this case, it probably has two. So it's not a function of x, and that's something that is a little different than what we've talked about before. Normally when we talk about equations, we think about 1x, 1y. So in this case, this equation is going to look a little different. We can still make an equation for it, it's just not a function, and I hope that makes sense. So if we think about this, this x and this y and the radius and how they're all related, if we make a right triangle right here, this little blue one, if I look at the horizontal length here, that is my x coordinate. That is the distance that I go in terms of x. Same with the height, that would be my y coordinate. So I can make an equation relating x, y, and r just using Pythagorean theorem. Since r is the hypotenuse, r squared has to equal x squared plus y squared, since both of these are legs of the right triangle. So that's the equation of a circle that's centered at the origin. This is being the radius, and then x and y are just x and y. So let's take a look at another case here. What if it's not centered at the origin? What if it's centered at some point, let's call it HK. Okay. Well, a very similar logic applies. This circle still has a radius, and it still has x coordinates and y coordinates. It's just been bumped over. So if I think about this distance right here, well, it's not x, it's whatever this distance here would be. Since this distance is h, and this total distance is x, well, this little bit right here would be whatever x minus h would be. And a very similar argument for y, this would be whatever y minus k would be. So how this affects the formula, well, very similar. We again use Pythagorean theorem because this can again be a right triangle. So we have r squared equals the quantity, in parentheses here, x minus h squared plus y minus k squared. Now, ultimately, if you remember just this formula, that'll be fine. I just wanted to give you an idea of where it's coming from. In this formula, r is your radius, and then h and k, these are the coordinates for your center. And keep in mind, there is a little minus here, so you may have some sign flips to do if you're making an equation. So HK, that's your center point. So let's see what this will look like in practice. We've talked a lot about the theory, we've talked about where they come from, and let's just keep in mind here our formula, r squared equals x minus h squared plus y minus k squared. So if we look at our example, we want to know what is the equation with a center at -3, +7, and a radius of 5. So all the information I need is already here. We just have to plug it in. So if I look at the radius, that's 5. So I just have 5 squared is equal to x minus h, which is up here, which is a -3, and then I square that. Then I look at the 7. So I'm going to have plus y minus a positive 7 squared. Now, I'm cool if you stop here. That's an equation. If you wanted to simplify a little bit, you could. You could say 25 equals x plus 3 squared plus y minus 7 squared. That's one example of how we can use it. You might also have some questions involving diameter. If you can extrapolate the radius from that, if you can figure out the center, then you can write an equation, and vice versa. If you were given this equation, you know what the radius is. You just take the square root of this number, and you just flip the signs on both of these numbers. That's your center point. So you can use this both ways. It just tells you where the radius is, or what the radius is and where it's centered at, which would make sense because each circle is defined by a center point and its radius. If you think about any given circle, you can determine what it is just on those two things. And it would make sense that the equation would have all of those built in.